Hello students, a very warm welcome to JEE English by Unacademy, India's leading and largest JEE test preparation platform. And guys, today we are going to get started with a very interesting topic. We'll go through, sort of expression or a theory that is going to make our life easy for calculating all this, electric flux related problem. Okay, it should have been, altogether as a different thing. But we are done with the Gauss Law, and today what we are going to do is we are going to solve some problems around electric flux and also understand this concept of electric flux, and finally come up with a theory that is going to be super easy. Okay, that's going to make your life super easy. All you need to know is that expression, and you will be able to solve any problem in any of the given different problems in your exams, or let's say in your competitive exams or during your normal time. Hi Divya, hi, good evening guys, and a very warm welcome. And students who know me well and good, if not, I'm Murlidharan Gopalakrishnan. I completed my MS in electrical engineering from one of the top ranking American university, and I'm also an IITian who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams, and I've filed 25 patent applications in India and abroad. I have a track record of winning several national level science and tech competitions. And students, that being said, if you don't have a Telegram app yet, download it from Google Play Store and App Store, and just click on to this link. This link is available in the description box below, or type in JEE_English. So with this, you will get onto our Telegram channel, and what can you expect from this Telegram channel in time and before time updates on every lectures happening on JEE English, or any lectures we conduct even on Unacademy Learning app. Okay, so you may want to check out our Telegram channel and join our Telegram channel so that you can get updates on time without any delay. And not only that, you can get also updates before time. Okay, if the class is happening at 7:30, you will be getting updates way before than any other channel will be giving you. That being said, students, this Sunday from 11 a.m. to 2 p.m. we'll be having an interesting class on capacitors, which is going to be the A to Z series on capacitors, and we'll be on the part 3. So 11 a.m. to 2 p.m. don't forget, on Sunday it's a free of cost special class, but on Unacademy Learning app. Okay, I'll tell you what is this Unacademy Learning app. Most of you must have downloaded it. And not only that, on Unacademy Learning app, you also have access to A to Z of units, dimensions and measurements. A complete series on units, dimensions and measurements, just in 5 back-to-back sessions. You can attend these 5 sessions to learn everything that you want to learn around units, dimensions and measurements, and possibly solve any problem around units, dimensions and measurements. And why you should attend units, dimensions and measurements lecture? Let me tell you, it's the easiest topic, less time consuming. Typically, you get 3 to 4 questions combined in JEE Mains and JEE Advanced. Okay, so this is something that you want to cover. Easy questions come from this topic. Don't miss it out. It's available on the Unacademy Learning app, guys. So yes, so first of all, you need to download Unacademy Learning app. You need to type in Unacademy on your Google Play Store and App Store, and the first search result is going to be Unacademy Learning app. Just click on to that link and click on the install button. Don't hesitate, because once you download this app, you will get access to many such free of cost special classes. Not only that, you will get live notifications on any special classes that are happening every day, and more importantly, you will also get access to free of cost features like quiz, etc. So in this quiz, you will typically get to see questions like what you can expect in JEE Mains and JEE Advanced. So many model problems. So you want to install that Unacademy Learning app, and don't hesitate to do that. Do it quickly, guys. And that being said, students, if you're looking for a champions tool for your JEE Mains and JEE Advanced preparation, and this is the right time to get started. I'm talking about champions tool, Unacademy Subscription, where you get access to structured program from the best educators across the nation. And this is that one platform where we have aggregated all the best educators across the nation for your JEE Mains and JEE Advanced preparation. In fact, we have legends like DC Pandey sir on this platform. So this is the awesome thing about Unacademy Subscription. Not only that, guys, we also give you an access to the best in class technology for your JEE Mains and JEE Advanced preparation, and you will get the feel of JEE Mains and JEE Advanced exam environment, and more importantly, it's going to be a structured program where you'll be attending classes, daily interactive classes with your favorite educator and the best educators across the nation. And along with that, you will be undergoing, like an intensive and extensive program where you will be also getting dedicated doubt clearing sessions on each topic. And moreover, you will also be attending, national level test series and etc. Yes, this is the best platform that you can have, the best tool or the best thing that you can have for a JEE Mains and JEE Advanced preparation. And if you can afford it, this is the best thing. All you need to do is you need to click on the left hand top corner extension bar, choose plus as your option, and then you'll choose IIT JEE as your goal. With that, you're preparing for both JEE Mains and JEE Advanced, and then you'll click on the get subscription, and with one subscription you'll get unlimited access, guys. That is the speciality of this Unacademy subscription. Hi Kaushik, hi. I will come to your question, just give me a couple of minutes, okay? And that being said, students, you know what, the price is also quite reasonable. For the kind of value you get, it's only 2,100, less than 70 rupees a day. And you can apply Murlidharan coupon to get the best discount on your subscription purchase. So to get to 2,100 rupees or less than 70 rupees a day, you need to apply Murlidharan coupon. So do not forget to do that. And this 24-month program is typically for 9th, 10th and 11th. Okay, majorly 11th class students, but also 9th and 10th class students can get started now. And let me tell you the amazing thing about Unacademy subscription. We also have convenient payment modes for you, which takes away, that too with our in-house feature, we take away the burden of paying all the fee at once. So you can make use of our pay in parts option, our in-house pay in part option, to split your payment into multiple parts. And we also give you access to no cost EMI, and this is that kind of EMI where you don't have to pay any interest. So yes, these are like the two interesting payment options for you. We also have other traditional payment methods, and you can check them out. And that being said, students, if you're looking for a 12-month subscription, we also have that. And this is typically, meant for, 9th class, 10th class, and it's typically meant for not 9th and 10th, but 9th and 10th, you should be going for 2-year subscription. This is meant for long-term and dropout students, okay? Or someone in 12th class and aspiring to only prepare in 1 year. This is the thing for it. It's typically a 2-year long journey, but if you're a long term and dropout, we have dedicated programs for you at a very reasonable cost of less than 2,900 per month. So this was going to cost you less than 2,900 per month, only 2,888. And you can apply Murlidharan coupon to avail the best discount on your subscription purchase. So to get the best discount, apply Murlidharan coupon, and you know what? This is the best price point you'll be getting on 12-month subscription, and by applying Murlidharan coupon. So do not forget to apply the coupon. Do not forget the discount. And that being said, we have 6,000 plus materials for your JEE Mains and JEE Advanced preparation, and 1,000 plus programs recently hosted. And this is the time to get started, because most of the programs are beginning now. And that being said, guys, I've launched a course just now on Optics Basics to Advanced. It's a comprehensive, it's a full-fledged course on optics. It's a comprehensive course in which we'll be covering both ray optics and wave optics, and in bits and pieces, in every details, in nooks and corners. So it's the basics to advanced course. So you may want to attend it even if you don't have any like understanding of optics, or if you don't have any previous knowledge of optics. You can still attend it, and you can still attend it if you're already well off with optics, because we'll be covering it from both perspectives. So that is the awesome thing about this coursework, and you may want to attend this. And guys, yes, enroll soon. If you're already on plus, if you're planning to purchase a subscription, this is the time. Just we have completed few lectures. You can enroll and start attending the recorded lectures and complete everything right now. And yeah, practice makes human perfect. And today's topic does not require practice, but only a mere understanding of a concept. Let's get into today's topic, and do not forget to share this video. Do not forget to like this video. We are going to do something very interesting. We are going to look at the easiest way to solve electric flux based problems, a new theory around this, and that is going to make our life very, very easy. So like this video, share this video, and click on that subscribe button and bell notification to get timely notifications. Click on that like button, guys, and click on that share button. Don't forget to do that. And before we get into lecture, we'll get into the question of one of the students. So we have a question from Kaushik. So how is Resnick Halliday Walker for JEE? Really good book. So yes, Resnick Halliday is one of the best books for your JEE Mains. Not actually for JEE Mains and JEE Advanced preparation. For conceptual understanding, it's very good. But I think right now there are dedicated series for JEE Mains and JEE Advanced. Really good book. You get to understand things in detail from very basics and very different application oriented things. And not only that, Resnick Halliday is very good for your conceptual understanding. You need to anyway combine Resnick Halliday with one or the other book. Either it should be HCV or DCP. So try to combine, your Resnick Halliday with one or the other books. Else, it would be little bit, actually, it wouldn't be all enough for your JEE. It would be good for your conceptual understanding, but still you need to cover some other book along with it, and which is possible because Resnick Halliday, if you go through it dedicatedly, it does not take any time. It has a lot of clarity, so your concepts will be clear. Alright, let's get into the topic then. We'll get started with just a little bit of revision. So if you remember what is electric flux, when speaking in terms of its definition, it's basically the number of field lines passing through any given surface area. If this is the given surface area, we'll be counting how many field lines are passing through it. But you know that field lines are just an imaginary concept. So hence, to quantify it, what would we say? We would say electric flux is equal to E dot A. Okay, electric field vector dot area vector, and what is the direction of area vector? Perpendicular to its surface. And what is the magnitude? Area of the ring in this case, or area of whatever, like how you have in that case. Okay, this is basic flux. That is basically all the electric field intensity available in the that unit area, or that area that you're counting. And we are taking dot product anyway, so if even the ring is slanted, and we'll be getting the projected area and really counting the number of field lines passing. And that being said, what was Gauss Law? Gauss Law said a very simple thing: don't do this much, don't complicate things very much. What I'm saying is, if you want to find flux in an enclosed area, like in this case of a sphere, just do a thing: find out or count the amount of charges, or find out the amount of charges enclosed in the sphere, and then what you need to do is just divide it by epsilon naught or epsilon, and then you'll find the electric flux. That is what Gauss Law says. A very simple theory by Gauss, which makes our life very easy. Okay, really easy. So let's get into a question then, and I'll give you a couple of minutes to have a look at the question. You can get started, and today we are going to go through that interesting theory, and everything will be just based on the two one line expression, and we'll be solving everything based on that expression. Do not forget to share the video, do not forget to like the video. So electric flux, so we'll be also exploring different cases of electric fluxes in this lecture. So electric flux through the given volumetric shell space with open base. So this is a part of a sphere, like a shell sphere. I mean, not a solid sphere, but a shell based sphere. And what you have is an open base. So it's like a thin shell, right? It's like a thin shell, a part of a thin entire like spherical shell, and it has an open base, means it's not closed. And now they are saying, it is at a distance d by 2 from a point charge plus q. Okay, and the circular cross section of the shell base has a radius of root 3 by 2 d. This is d by 2. This is root 3 by 2 d. Okay, now find out the flux through this surface. Okay, through this given volumetric shell. Okay, it's basically that thin line. It's basically area only. Whether it's 0, whether it's q by epsilon naught, whether it's q by 4 epsilon naught, whether it's q by 2 epsilon naught. Quickly get started, students. It's a very easy problem, and let me tell you, you'll be able to do it. Okay, by the end of the lecture, you'll be able to do everything. Just try to understand what I'm going to do next. So that is like just a one-line thing that you need to apply all the time, and post that this concept will be totally clear. It's only a concept based thing that we are going to do today, like a small expression that we will be deriving and using throughout our finding out any electric flux. But there are like few cases for which it is valid. I mean, it's valid for every case, but in that situation you need to find out I'll tell you what you need to find out as we move to the lecture. Okay, let's get started with the question then. So there is a plus Q charge over here, and now what was said, you need to find out what is the electric flux through this open base shell. Okay, sometimes the radius of the shell will be given to you, sometimes the radius of the shell won't be given to you, but don't worry about it, you can find out the radius of the shell, right? So this is a spherical shell. You can imagine it to be something like here, that is like, let me draw this again. What is this? The sphere is extending in all the directions. It is not a single space, guys. This is not this part of that sphere. If part of the sphere is cut out, this is what it would look like. Okay, this pictorial representation may look like it's cut off of a very small sphere. Maybe it's like a huge sphere. Okay, now the thing is, you need to find out electric flux through this. What I'm going to say is, here starts the first hypothesis of this thesis. So what, this is a point charge, is not this huge, this is a point charge. Let's assume everything is being radiated from here. So this is just a concept, there is nothing new in this. So there are like field lines flowing through this space. So what I'm saying is, there are field lines all around the space due to this Q, plus Q in this case. Okay, there are field lines throughout the space, just like how a point charge would behave, and radiating all the field lines in all the three-dimensional direction. Okay, it's 3D, try to understand, it's 3D, 3D, 3D and 3D. Now what I'm saying is, if at all, I'm able to find out it's a logic based thing, I'm able to find out this solid angle, let's say sigma. I'm able to find out this solid angle sigma, then if the flux through this entire thing, how much is the space? 4 pi. Then this, okay, we are starting out very logically. Think about it. This is the entire sphere, and this blue color part over here is just a part of the sphere, right? That part of that shell. So what I'm saying is, if this entire part 4 pi can create a flux of Q by epsilon naught, then how much would this this solid angle create? That is the question. Divide both the terms, it should be same, right? Because it's uniform field around plus Q. Simple. I hope you understood the theory. Let me come to this again, because this is a very important thing. This is the easiest way to solve any given problem. Okay, you'll see even this is true for many other things. So what I'm saying is, if there is a part of a sphere cut out, now you need to find out flux through this part of that sphere shell. You will typically find out the solid angle and say that if this is the solid angle, this would be having some ratio of the 4 pi thing. Okay, 4 pi is the total solid angle which contains plus Q charge, so it's Q by epsilon naught. So you are within sigma, how much you will have? Within sigma you will have sigma divided by 4 pi into Q by epsilon naught. That's it. The end. Nothing more. Okay, let me do a thing. Let me first of all get started with the solid angle calculation. I hope you understood the thing. If with 4 pi, if the total flux, imagine in 4 pi the total flux would be how much? Plus Q by epsilon naught. Excuse me. Yeah. So this would be q by epsilon naught. And within a solid angle sigma, what it would be is the question. What is the flux within a solid angle? So what I am saying is, within that solid angle sigma, flux is going to be how much? Sigma divided by 4 pi into, really simple guys, really simple, isn't it? Within the all spherical shell it would be q by epsilon naught, and within that spherical shell it would be sigma divided by 4 pi into q by epsilon, a modified form of Gauss. Okay, but finally this may not work, we'll come up with a new thing. So, but I believe this is good enough for your exam. So if I'm going to draw this triangle, this is root 3 by 2d, and first of all let's understand one thing, this theta is half angle, not complete angle, this is a half angle subtended by this spherical shell at the charge. So what is the relation between half angle and solid angle? Solid angle is equal to 2 pi into 1 minus cos of theta. That is it. That's all you need to do. Now I need to find out the theta. It's not a very challenging task. I'll tell you why. We know for a few things, and we can quickly find out cos. We need to find out cos theta, not even theta. Okay, do remember we need to find out cos theta. This is theta. This is how much? This is d by 2. This is root 3. So this, think of this being shifted over here. Just the radius of that ring, right? Radius of that base, not the ring, the base of that spherical shape. Okay, this would appear something like this. Hope this is clear, guys. Very simple, very simple, isn't it? I told you at the beginning, any question is going to be simple given that you move very logically. Any problem ever. Okay, and this is 90 degrees, this is lying at the center of this shell space. So this is 90 degrees, so this should be how much? Under root of 3 by 2 d whole square plus of d by plus d by 2 whole square under root, which is nothing but d. 3 by 4 d square plus d square by 4, that is d square under root, this is d. So how much is cos theta? Cos theta is equal to 1 by 2. It's basically actually 60 degrees, but that's not important for a calculation. So now I'm going to just use this in this equation. Doesn't it make sense? Yes, it totally makes sense. First of all, let's write down the value of sigma. The value of sigma is going to be 2 pi into 1 minus cos theta. In our case, cos theta's value, I'm directly substituting it. I hope you understood that part. I'm writing down directly the value of cos theta, guys. Here we had this cos theta, right? I'm substituting the value of cos theta from here, which is nothing but 1 by 2, right? That is what I'm doing. So it would be pi. So 1/4 of the total thing is what should be presented. Quite simple, isn't it? So what is the electric flux now? If you substitute in that equation 1, okay, you substitute in the equation 1, let's do a thing, let's give the equation some names. This 1, this is 2, this is 3. Okay, from 2 and 3 you have this. Just I'm changing the color. From 2 and 3 you have this. Simple, isn't it? That's it, guys. That's it. Physics can be really simple if you apply the logic. That's the beauty of physics, isn't it? Sometimes it can be really simple. Okay, so into q by epsilon naught. Right, so what is this? This is nothing but q by 4 epsilon naught. What is flux? Flux is Q by plus Q by plus Q flows minus Q to be minus, is plus, it is plus. There's a difference between negative flux and positive flux. That is it, guys. That is it. Simply do this. You can, calculate the angle, do the flux. Pretty, like tiring, time taking, etc., etc., etc. Rather imagine this to be a part of the sphere. Think about the solid angle and take the ratios. Complete the problem quickly. If you knew this concept, this problem could only be like 30 seconds. Okay, finding out the angle 30 seconds, doing that one by division, etc. That's max to max 1 minute. Alright, let's get into the next problem then. Okay, so now what is the difference between the earlier problem and this problem? Now we need to find out electric flux through the given volumetric shell space with closed disk space at a distance d by 2, same distance d by 2, and same cross-sectional area of the shell base or the disk is root 3 by 2d. Okay. Think about it carefully. This time this is a closed structure. Given volumetric shell with closed disk base at a distance d by 2, and this shell base as a radius, or this disk as a base. This is like not a single surface, but this is like you can imagine this to be part of the shell, and this is covered. Okay, now work around it. What do you think? It should hardly take 20 seconds, students. You can quickly get the answer. Not even 20 seconds. If you know the concept, it's very simple. We discussed this yesterday. The earlier one was open shell, now this is a closed shell. Answer should be, what should be the answer? Answer should be simply 0, isn't it? Should be 0. Don't you think so? It should be 0. Why it should be 0? Let's understand this. There's nothing to understand, and there's no charges enclosed in this closed structure. Any field line passing through the disk is exiting. The amount of flux entering is same as amount of flux exiting. Hi Aradhya, hi, good evening. So it is really that simple. Flux entering is equal to flux exiting. So net flux is what? Let's call this net flux as phi net. Okay, I'm just changing the name, just giving it a subscript like 5 of net. Phi net is how much? Flux entering plus of flux exiting. Hence this is 0. The closed surface, closed 3D surface. Okay, anyway 2D surfaces are not closed. The closed 3D surface. Right? Simple, isn't it again? Just concept based thing. So you can think from Gauss Law perspective as well. You don't have to think from this point charge, flux entering is flux is exiting. So what I'm saying is first like concept is flux enters, the same flux is also exiting. Flux enters through disk base, and the flux exits through shell top, or whatever it is, shell surface, or the part of this shell surface, whatever it is. You understood, right? Don't think to the shell surface. Wasn't it easy, guys? Shell surface. Right? Yeah, good, Aradhya, good. And that's all you need to know. And the other way of thinking about it is, this is a closed surface. What is the charge enclosed? Zero. Why would there be any flux? Flux would also be zero. The closed surface, right? If it was an open surface, if it was a 2D surface, it's a different thing. In fact, you know what? It is not a 2D surface, but anyway, it's a closed surface, so it would be zero. Charge enclosed is zero. And one other way of thinking about it is, flux entering is exiting. One you would give negative, other would be positive. Flux, generally you take flux entering as negative. Okay, answer should be zero. Simple. Let's move on to the next question. Again, we are going to get started with an awesome question. Good, Aradhya, good. There are two charges, plus Q and minus Q, and are placed asymmetrically about the spherical shape. Notice the diagram with that, plus Q red color charge, minus Q blue color charge, and there is, like a Gaussian surface or whatever it is. It is a shell, the Gaussian spherical surface in orange, which has radius r, but this plus Q charge is placed asymmetrically with respect to minus Q charge. I mean, these both are placed asymmetrically. One is placed at r by 4 and the other is placed at r by 2. Now, then what is the electric flux through the given Gaussian surface? Quickly, students, quickly. Two charges plus Q and minus Q are placed asymmetrically about the spherical center of the Gaussian surface at radius r by 4 and r by 2. And what is the radius of the Gaussian surface? R. Then the electric flux through the given Gaussian surface is quickly. It's a 2-second problem. What should be the answer? What should be the answer? Guys, quickly. Should we get into the problem? Can't you just answer it by looking at the problem? Shouldn't it be 0? It should be 0, guys. Why it should be 0? Let's go by Gauss Law. First of all, I am finding out this is the Gaussian surface. This orange sphere is the Gaussian sphere or Gaussian surface. Right now, what I am saying is, if this is the Gaussian surface, what is the charge enclosed in it? We have, I'm going to give a 2 different color to that, just for the sake of understanding. One is, it does not matter if it is placed asymmetrically. You can also understand it through concept, don't worry about it. We have plus Q and we have a minus Q. Both gets cancelled out. Is 0. So charge enclosed is 0. From Gauss law, we can say that charge enclosed is 0, even though it is placed asymmetrically. Hence, net electric field is also 0 through the Gaussian surface. Electric flux is 0. Net electric flux is nothing but charge enclosed by some epsilon. In this case, this is 0. Right? What is Gaussian surface? Okay, Aradhya, I'll come to that point. Good question. And what is the question of Ritika? Ritika is asking that, sir, in HCV there is a relativity chapter, but it doesn't even ask. So if it's not in your syllabus, then don't do it, guys. HCV is sort of an MSc book. It's actually not an IIT JEE book. It's a little advanced book. It's written by a professor from IIT Kanpur, HC Verma, of course. If you're watching YouTube, you can also see a lot of videos from him. But the thing is, it's not necessary that you complete HCV even for a JEE preparation. It is a little advanced book sometimes. Okay, and yeah. So you don't have to do it if it's not in a syllabus. If a chapter is not in a syllabus, you don't do it. That's it. Simple. Don't waste your time. And Aradhya's question is, what is the Gaussian surface? So Gaussian surface is imaginary surface that you draw, like a Gaussian 3D surface generally. to find out what is the flux around that area. Okay, so for an example, I am saying I want to assess electric flux from here at a point R, then I will draw a sphere. Or if I'm saying if I want to assess, you'll understand that more and more when we move to the next class. Typically we make use of this to either find electric flux, or from electric flux we'll try to reduce electric field. Okay, so we'll try to, if at this at a distance r perpendicularly, if I want to find out throughout this place, I'll draw a cylindrical Gaussian surface. So Gaussian surface is basically an imaginary surface that we draw to find out what is the electrical flux. Sometimes Gaussian surfaces will be given to you, sometimes you need to draw the Gaussian surface. So drawing Gaussian surface thing will come up tomorrow. Don't worry, don't miss out the class. And given Gaussian surface is the kind of the problems that we are dealing today. Okay, good. That's very good, you understood it. So, but is it little counterintuitive to say that it is placed asymmetrically, and why should the field be 0? Now think about it in this manner. Okay, now this plus q charge is creating some field at all the edges, which is of greater intensity, etc, 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 etc. But similarly, minus q charge is also going to create some exact field in the opposite direction. According to Gauss law, this is true. And they would eventually cancel out the field due to each other. Whatever flux is exiting due to plus q will be the flux entering due to minus q. So the direction is wrong. Okay, will be flux entering due to minus q. Right? That's it. Flux enters due to minus q, negative flux. Flux exits due to plus q, positive flux. You need to basically, given a Gaussian surface, what will you do? The first thing you'll assess is what is the charge enclosed. Say that, alright, at the, they'll say, from so for an example, like what Aradhya asked, when would this be useful? So one case would be you would have some uniform charge distribution, and they will ask you at on like a rod or on a cylinder, on a sphere, and how would you find out electric field at some point. And for an example, in this case, let's say I'm trying to assess electric field from this point to this point, or you simply draw a Gaussian surface in 3D at a radial distance r from the center. In 3D, from this point at r distance, I'm trying to assess electric field, and I am standing at r by 4 from plus q and r by 2 from minus q. Now I need to assess the electric field. Then I will make use of Gaussian surface. Depending upon what is the application, if it's all in 3D in all space in r cap direction, then sphere is the ideal one. If it's a uniformly distributed charge along a rod, then probably cylinder is the best Gaussian. Alright, I believe this is clear now. Let's move to the next thing. So depending upon the application, you'll be choosing it. Alright guys, simple one again. Two charges 2q and q are placed symmetrically about the spherical center of the spherical Gaussian surface of radius r at a distance r by 3 and r by 2, again asymmetrically. Then this is asymmetrically. Then the electric flux through the spherical Gaussian surface is how much? Come on Aradhya, get started. Now I believe this is clear guys. What should be the electrical flux from this point O in radial direction r? Okay, at a distance r in the radial direction r cap. Okay, there is a plus 2q charge and q charge which are placed asymmetrically about the spherical center at a distance r by 3 and r by 2. Asymmetrically, okay. Anyway, it's not symmetrically, you understood it. It's asymmetrically. Okay. As you can see in the picture, what should be the electric flux? Quickly. I'll wait for maybe until like 30-40 seconds, because it is that much time only you need. It's a free space. So you can quickly do the question, guys. Don't it's one step question, so you must be coming up with the answer very quickly. What is electrical flux though? Like you're talking about everything electrical flux. We're finding out electrical flux. Is it sort of are we finding out the amount of electrical energy passing through a surface area? When we are doing E dot dA, what is E? If you forget the direction, it's basically good. Very good, Aradhya. So yes, what is electrical flux? Very good, Aradhya. Very good, family home. Very good. No, it's not 0, guys. It's T. Sorry. Very good, everyone. Try it out, Aradhya. Family home, good. Okay, let's get started on this. Okay, what is the electrical flux? Why do we need to know electrical flux? If you remember the expression, electrical flux is nothing but E dot A. This is true for any flux, right? What are you trying to do when you're doing E dot A? What is E? Think about E separately. E is nothing but electrical field intensity. If you forget the R cap, it is electrical field intensity. And if you're multiplying it with an area, what are you getting? The total electrical field intensity in an area. Okay, so you are measuring electrical energy in an area. Okay, but exactly you know what to do when you are measuring electrical energy. So let's get started with this question then. Alright. So what is the charge enclosed in this orange sphere? Both are not given plus q etc. Both are of same sign, 2q plus q. Okay, so charge enclosed is 3q. It is placed asymmetrically. Does not matter, I told you. Does not matter. So what should be electrical flux? Electrical flux should be as simple as this is charge enclosed. It should be simply this should be from Gauss law. It should be 3q by epsilon. That's correct. That's it. Very simple. Good. So what should be flux in that case? It should be 3q by epsilon. Right? This much amount of field intensity would be exiting through 4 pi r square area. This much. So now you are getting a feel of electrical flux. So it's all exiting, right, due to 2q and 3q, etc. It's exiting. This much amount of electrical field intensity would be exiting from the given Gaussian surface or at a distance r from this point 0. You're noticing from the point 0, it's a little relative thing. Okay. 4 pi r square. Okay. Now how would this two charges minus 2q and plus q are placed this time symmetrically at a distance r by 2 and r by 2. Now about they are placed symmetrically about the spherical shell of the spherical Gaussian surface of radius r at a distance r by 2 and r by 2. So both are placed at r by 2 and r by 2. Then find the electrical flux through the given Gaussian surface. Whether it should be 0, whether it should be q by epsilon naught, or whether it should be minus q by epsilon naught, or whether it should be 3q by epsilon. Why don't you get started? It's a very simple problem. Just to give you a feel of different kind of problems. When you had minus q and plus q, what happened? It was zero flux to the Gaussian surface. And when we are talking about minus, we are like similar charges, like charges. What was the electric field intensity exiting that Gaussian surface? It was 3q by epsilon. Now we have minus 2q and plus 2q, but placed symmetrically. But does that matter? No, right? Good. Really, see, yeah, good, very good. Very good. Amazing, guys. So flux, you can note it down by negative. Negative is just a sign convention which is saying that the more number of field lines should be entering. First of all, let's understand what is charge enclosed. What is charge enclosed in this case, students? It is minus 2q. Okay, this guy minus 2q plus of q. That is the charge enclosed in this Gaussian surface. I hope now you are getting a feel of what we are calculating in the Gauss law. Not, I do believe it's not exactly electrical flux exiting, but relative electrical flux. Okay, so what should this be? Minus q. Right? Simple. Now, what is from Gauss law? We can say phi is equal to charge enclosed by epsilon naught. Good, really good students, really good Aradhya, really good family home. Both of you have done it really well. Okay, minus q by epsilon naught. Why have I taken this problem? You should not be marking plus q by epsilon naught, because there is a difference, guys. There is a difference. Many people don't know this. Okay, so try to understand this. There is a difference between having minus 2q and plus 2q. Okay, what do I mean is net charge being plus q and net charge being minus q, because here more number of field lines are entering the system due to minus 2q. Okay, if I'm going to talk about this guy, minus 2q thing, this is a concept very not known to many people, guys. Okay, simply either they are getting it because they're doing charge enclosed thing, but this is, try to understand it conceptually. Okay, so more number of field lines are entering. Now in the case of plus q, what is happening? You'll be drawing lesser number of field lines, less closer to each other, etc. So lesser field lines are exiting, hence minus q by epsilon naught is unique, and it tells you that more number of field lines are entering. Very careful. Whether if it's plus q by epsilon naught, we are not talking about magnitude, we are also talking about sign and electrical field. Okay. Entering the system, entering this Gaussian surface, spherical Gaussian surface. So we did all the model problems around flux that you want. So I believe this should not go wrong anymore. All right, good. Now let's come to a very interesting question. Now you have a given disk surface and with radius 4d. This guy has a radius 4d. And at a distance 3d from minus q point charge. Now what is the electrical flux that is passing through this disk? It's a 2d surface now. Okay, it's clearly a 2d surface. This disk can be placed in just x and y axis, but total system is 3d. But anyway, now what is being asked is through the given disk surface placed at radial distance 4d. Okay, as having a radius 4d, placed at distance 3d, axial distance 3d from minus q charge, what is the electrical flux? Get started. At least try to guess the approach. Draw the field lines, try to intuit something. I'll give you some time, take your time. You can take your time and intuit things. Try to intuit things. Draw the field lines, it will become clear. Its answers are given as 0, minus q by epsilon naught, minus q by 4 epsilon naught, minus q by 5 epsilon naught. Trust me, very easy. Literally, very easy. Intuit things, easy, guys. It's very easy. Draw the field lines from minus q. I'm intentionally not doing it for at least a minute or so. You take up the time, draw the field lines and try to understand what kind of system is this. Something related to like what we discussed in the beginning. Alright, I'll do a thing. I'll also get started. I'll start drawing the field lines. Answer should be... let me think. Just give me a moment, Aradhya. So there should be... good. Okay, it's family home. Very good, very good. Amazing. Pretty amazing. Yeah, very good. How did you get it? What did you do to get the answer? Hi Dinesh. Hi. So there are multiple ways of doing this question, but we'll make use of that, like the relation, the theory that we are making use of. But you might be wondering how in this case this is applicable. Good, Aradhya. Good. One way is there are some standard expressions to work around and you'll get the answer. Aradhya, how did you do it? But let me tell you about the easy way. So like some definite amount of field lines are entering. It's a minus Q charge. Correct it. Good. Okay, you have an expression. I'll tell you the other way of doing it. It's a very simple way. For any system, this is applicable. For any system, we'll be discussing two special cases. It is applicable for many systems, but you know what? You need to have your thing around solid angle. Okay. So why am I talking about solid angle? So if you remember in the first case, there was a disk base. Now what am I going to do is, I am going to draw a spherical shell around this. A small spherical shell around this. Can be, if you remember the case 1 and case 2. In case 1, what happened? We found out the, using solid angle theory or something like solid angle technique, we found out what is the, electric flux. In that case, it was exiting electric flux through the spherical shell. In the case 2, what happened? There was a disk and there was a spherical shell, and we said that this is a closed system. Amount of field lines entering the system is also exiting the system. How did that happen? All the field lines had only one way to enter, that was the disk. It was always entering through the disk. Now, in this case, where it is exiting through, it is exiting through the spherical shell. I am drawing an imaginary spherical shell. A spherical shell does not exist. Do understand that? I will tell you the logic behind it. If at all I find out, if at all I take this to be a closed system, a very good technique to work around, guys. If at all you take this to be hi Samir, good. If you integrated it, it's little bit time taking if you're integrating it. Good family home, but I'll tell you a very simple logic. If at all it was a closed system with a disk base and a spherical shell on the top, or a part of the spherical shell, right? It's not going to be a complete spherical shell. It's a part of the spherical shell on the top. Then what are you getting? You'll get net field to be, net electric flux to be 0. Amount of field lines entering has to exit, or in this case, amount of field lines entering has to exit, whatever it is. So now if at all it was just disk, I can find out how much electric field lines are entering in this case. In the earlier case, it would have been exiting. Try to correlate with the case 1 and 2 we discussed. In case 1, we didn't have a disk base, hence we found out how much was the electric field through it, or electric flux through it. And in the case 2, we had a disk base, and we said that whatever field is entering through the disk base is exiting through the shell. Similarly, in this case, what I am doing is I am drawing a shell. I'll find out the flux through this shell and say that it is equal to that of the ring, that of the disk, not ring, sorry, the disk, right? Thus, it's easier than you think. Why? We know the solid angle thing, the solid angle technique. So forget the electric field flux lines are entering anyway. When we substitute the sign, this will be taken care. Don't worry about it. So this is the logic. I drew a complementary surface and I said that whatever field lines are going to enter, or in this case, through the shell, enter through the shell, will be exiting. So it's a little bit altered in this case. So I could have written it down as, this is the exiting surface, that is the entering surface. But it was plus Q understood. This is clear? Very important concept. Always draw the complementary easier surface. Okay. It's minus Q, so it's entering and exiting. Now if I find out this, what would I do? Find out the solid angle. I will find out the half angle. Got it? Got the simplest way. Good, Aradhya. Good, family. Very good. You know both of this. It's very easy. Very, very easy. But this equality only exists with a negative sign. Do remember that. Okay, actually it's with a negative sign. So anyway, right? So what would I say? First of all, find out the triangle. What is the triangle? I need to find out the cos theta, half angle. We have to find out the half angle. Let me draw it neatly. This concept is clear. Rest is just cakewalk, guys. Understanding this only would take time. If you understood that, there's nothing left to understand. This is theta. This is 3D. This is 4D. How much this should be? 3 square plus 4 square is how much? 25. Under root of 25 is 5. This is 5D. What is cos theta? 3 by 5. Cos of theta is 3 by 5. Why are we doing this? To find out this solid angle. This solid angle. This solid angle is how much? 2 pi into 1 minus cos of theta, which is how much? 2 pi into 1 minus of 3 by 5. How much is that? This should be 4 by 5, right? So we'll get, I think it's visible. The solid angle is 4 pi by 5. Okay. Simple logic, guys. So we have solid angle which is 4 pi by 5. And if this was, now let's come to that part where we correlate things. If minus Q, okay, not like that. I believe write it the other way around, it will be a little confusing. Let's do a thing. Through 4 pi, how much flux is entering? In this case, it is entering minus Q by epsilon naught. Then in the case of solid angle 4 pi by 5, how much would be happening? It would be, flux would be, this is the flux, right? This is what, this is the flux total. If it was like hypothetical total spherical surface, we extend that shell, draw that sphere, it is what it would be. So now you simply say that this thing is nothing but phi e through this solid angle is going to be what? Solid angle divided by 4 pi into that of minus Q by epsilon naught. Okay, so in this case, how much this is? Substitute the value of solid angle. It is 4 pi by 5. You will get it as 1 by 5. I think this is clear, right? I don't have to do the calculation. Substitute the value. So through 4 pi by 5, it's simple. 1 by 5/5 of that flux will be entering. Minus Q by 5 by epsilon naught says that it is entering. It is, this concept should be clear. It will be helpful in future, don't worry. Right? Alright, that's it. It's a very simple concept. Draw a complementary surface, then find that solid angle for that complementary surface if at all possible. Simply find out. Over. So with this, we'll come to an electric flux solid angle theory. So this theory we can make use to find out any such equations and any such given condition. So typically I've assessed it for two conditions. One was disk, other was part of a shell. You can try it out for rest of the things as well. What I'm saying is, if at all you know the solid angle dr, which is the solid angle, this solid angle in this case, solid angle, right? Entire thing. Okay, let me quickly erase this. And in this case, okay, in this case, this is the solid angle, right? It's solid angle, guys. It's solid angle, right? So I'm saying this is dr. If you simply multiply this with the radial field EQ at some distance r, if at all this was a distance r, you multiply that electric field at a distance r with the solid angle, you will get it. Okay, it should be actually solid angle area. This is nothing but solid angle area. That is when you get it. Or else what you can do is you can apply Gauss Law, Gauss flux. Okay, let's modify this equation a bit. Flux is equal to Gauss flux into solid angle dr. A simple expression to do this. So maybe this is something that you want to note down. Simple, very simple. You can apply for this case. You can apply for the case of disk. What would be the solid angle? Again, I repeat, this is the solid angle. Not so fast. Let's do this patiently. So if this is a point charge, this should be the solid angle. This should be the solid angle. Right, in this case, this should be the solid angle, and you do it typically using the half angle, right? 2 pi into 1 by 1 minus cos theta. So what was EQ in that case? You know, EQ was nothing but, I'll explain you what was EQ. EQ was 1 by 4 pi epsilon naught, or rather let's write it down this way, which we are accustomed to more. So KQ by R square. Okay, and what was the solid angle, you know, solid angle dr, which is nothing but 2 pi into 1 minus cos theta, or rather solid angle of solid angle into r square. Anyway, you will get Gauss flux, you know, this thing. I didn't notice that thing. You can write it, even write it down in a simplified manner using Gauss flux equation. That is it. You can always try it out either using complementary surface or either using the way we did it, complementary surface, or if it all, yeah, typically try to use complementary surface. Try to work out for different kind of geometries. It will be very interesting, easiest one. Which book to practice for JEE Advanced? Good question, family home. And which question to practice for JEE Advanced students? Do DCP, do HCV. Okay, do DCP, follow the lectures. And I think that should be good enough. For additional thing, you can either do an HCV or you can do a error. Okay, probably if you're doing HCV, right, and if your lecturers are following HCV, don't do it. Your lecturers are not following HCV, maybe you do HCV and follow the lectures. And previous year questions. I'm talking about electrostatics, specifically DCP. You can also follow HCV, either DCV or HCV, not both. Okay, too much time. And if you have time left over, go for error. All right. So that being said, students, enroll soon. If you're already on subscription platform, we just launched a very interesting course for your comprehensive understanding of optics basics to advanced, where we'll be taking every single topic in optics from basics to advanced, and this includes both ray and wave optics. Very good. If you have completed HCV, that's pretty awesome. And now practice PYQs. If you have completed HCV, practice PYQs and practice it. Okay, you're welcome. Enroll soon, guys. If you're on subscription platform, if you're on Plus, enroll to the optics basics to advanced. It has just been launched. Cover the recorded videos and come and attend the daily interactive classes. It would be very awesome. And it is happening from Tuesday to Friday. What time? 6 p.m. Just before this lecture, we will be completing this lecture. And if you're not yet on subscription, this is the right time to get started, because many courses are floated, in the view that you're going to prepare for your JEE Mains and JEE Advanced for this 6 months and this 1 year. 3 months and this 9 months, and so hence this is the time to get started. It has just been launched, and you can attend this course as well. And this also meant for your JEE 2021 target, a complete course on optics, in which we'll be covering both ray optics and wave optics. That being said, this Sunday we'll be having a special class on A to Z of capacitors at 11 a.m. So this is the part 3 of A to Z of capacitors at 11 a.m. and this would be happening, guys, for 3 hours or 2.5 hours, etc. But do not miss it out, because it's going to be very interesting. It's a free of cost special class, so don't miss it out. It's available on the Unacademy Learning app. You'll be soon be able to enroll in this course. It's a very interesting thing. We have already covered 2 parts. You may want to attend the rest of your 2 parts as well before attending this 3rd part. And that being said, do not forget to like the video. Do not forget to share the video, because once you share your knowledge, not only your knowledge doubles, but you also gain power, because you're training to brainstorm, you're training to gain more and more knowledge. With knowledge comes power. So do share the video, do like the video, do click on that bell notification, and do click on that subscribe button so that you get timely updates. And keep smiling, work hard and work smart to achieve your success. And students, if you are not yet on our Telegram channel, download Telegram app. If you don't have one, download Telegram app from Google Play Store and App Store, and click on to this link. This link is available in the description box below. And if you're already on Telegram app right now, you can just type in just JEE_English and find us. And this is the place where you will get in time, before time updates on any classes happening on JEE English or any such classes that we conduct. Our team, we have an awesome team of lecturers. And we conduct this lectures also on Unacademy Learning app. You can check them out. You'll get before time updates. That's the awesome thing about getting onto the Telegram channel. So one place where you would get all the updates before the time. And that being said, students, what, if you haven't yet covered units, dimensions and measurements yet, do cover it, because we have conducted A to Z series on Unacademy Learning app. And guys, you know what? This A to Z series is conducted in 4 back-to-back sessions, and plus a 5th model problem session, or complete session with different kind of model problems. You want to cover all of them, and this is all available for free of cost on Unacademy Learning app. And why units, dimensions and measurements? Easiest topic, scoring topic, and typically one of the most, or typically it is asked in your exam, both JEE Mains and JEE Advanced. If you have noticed, always and always there would be a question from units, dimensions and measurements. So hence this is something that you want to attend, because only 4 lectures, less time consuming, easy and asked in your exam. So what else do you need as a reason to attend these classes? And that being said, guys, if you are even attending from web-based version, do download Unacademy Learning app. If you don't have one, you need to definitely download Unacademy Learning app. Even if you are attending it from web-based version, why should you download Unacademy Learning app? There are thousands of reasons, but let me tell you few good ones. One is you would get access to special classes like this, free of cost special classes like this. And if you're a plus student, you can attend your classes from anywhere. Even if you're attending special classes, you can attend your classes from anywhere. And not only that, you will get live notifications on any such classes happening if you follow your educator. And more importantly, there's also a free of cost quiz feature, so you can attend free of cost quizzes with the model problems that may appear in your JEE Mains and JEE Advanced. So all you need to do is type in Unacademy on your Google Play Store and App Store, find us, which is the most downloaded learning app, Unacademy Learning app, and then click on that install button. And that being said, if you're looking for a champions tool for your JEE Mains and JEE Advanced preparation, we have the best one for you. I'm talking about the best tool that you can have for your JEE Mains and JEE Advanced preparation. Yes, guys, we are talking about Unacademy Subscription, where you have all the best educators across the nation on this one platform. And more importantly, do understand that you can also get your doubts cleared from these best educators. And guys, what is the advantage of getting an Unacademy subscription? You get to attend classes on a platform with the best technology that gives you the environment like what you would have an experience in your JEE Mains and JEE Advanced. So yes, the best platform with best educators. More importantly, you'll undergo an extensive and an intensive learning program, a structured learning program where you'll get to attend daily interactive classes with your favorite educators, but also get your doubts cleared, and you will attend test series and quizzes on the same. So that is the beauty of Unacademy, subscription. All you need to do is click on the left hand top corner, extension, choose plus, choose IIT JEE as a goal, get access to programs in both JEE Mains and JEE Advanced, and then you will get the subscription. And the other beauty is it's one subscription, unlimited access, guys. And that being said, if you are in 11th class and 9th class and 10th class, so typically 11th class students, 9th class students, 10th class students, this is the program for you since it's a 2-year long journey, and the price is also quite affordable for this valuable platform. It's less than 70 rupees a day, 2,100 per month. And how do you get to this price point? By applying Murli Live coupon, you will get the best discount on your subscription purchase. So do not forget to apply Murli Live coupon to get the best discount. And students, we also have a very interesting thing for you, that is our pay-in parts, our in-house pay-in parts, payment feature, which takes away the burden of paying all the fee at once. And you can also choose no cost EMI, which also cuts down the burden of paying all the fee at once. So this way you will be able to split your payments into multiple parts. These are 2 interesting payment options that you may want to explore. And we also have other traditional payment modes like debit card, credit card, UPI, etc. And that being said, if you are in long term or dropout, so you may want to check out the 12-month subscription. Why 24-month subscription? Why 12-month subscription? Because based on that amount of time, programs are planned. Anyway, you can enroll to whatever program you want. But if you're in, a long-term student, dropout student, or if you're in 12th class and if you only have 1 year for your preparation, then you may want to choose 12-month subscription, and you will get it at a cost of less than 2,900, at a cost of 2,888 only, by applying Murli Live coupon, with which you will get the best discount on your subscription purchase. So get the best discount by applying Murli Live coupon. Don't forget to apply Murli Live coupon to get the discount, to get the best discount. And do not forget to choose the right kind of programs, and do not hesitate to give the rest test series, and do not hesitate to attend the structured program. They are meant for your preparation. It's a complete in-depth understanding. And do not forget to enroll to the Optics Basics to Advanced course. And students, do remember, we do have 7,000 plus materials for your JEE preparation, 1,000 plus live programs that has been just posted for your JEE preparation. And that being said, take care, stay